So today, whoa, what happened? Where's the rest? He was offended. All right, so we're working with linear functions, and we're going to do a little bit more slope. We did slope on the last lesson that we did, but definitely linear functions. Our objectives today: calculate a line slope, write equation in point slope form, graph lines in slope intercept form, graph horizontal lines, graph vertical lines, recognize and use the general form of an equation, use intercepts to graph them, and if we have time, we'll do some modeling. Kind of funny because I think the other class already did this, but it's okay. We'll get her done. Thanks for not having your earbuds on your ears. Let's get to it. Anybody need the slide still?
Yeah.
Yeah? Check, check, check. Boo. I think there's something going on with the mic. All right. Let's get back. Okay. We'll get these, I think, as we go as well. So, when we were doing Algebra 1, we called slope a bunch of different things. One of them was rate of change, right?
Yes.
Average rate of change, to be exact. Average rate of change. We talked about rise over run. That was very elementary. We talked about the change in y over change in x. One that you're definitely going to want to get familiar with is delta y delta x. Delta y delta x. Greek letter delta, look like a little triangle. Delta y, delta x. In math, we use delta to represent change. So that's all it's really saying. Change in y over change in x. And you're going to get to see a lot of that in the calculus world as well. And since this is pre-calc, then you need to get used to the notation. And of course, the way we find the change in y over change in x is by doing a subtraction problem. And we usually call that y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And the last time we talked, I showed you guys how it is that we modify that by using the function notation versus our equation notation to go from average rate of change to instantaneous rate of change. And it sounds like you guys had some fun with that. That thing is also called the first derivative, which is going to probably be one of the first lessons you guys get to learn when you get to calculus, because first derivative is a lot of information. So let's move on.
No.
Let's not move on. Word of caution, both x's should not be 0, because 0 minus 0 is 0, therefore making the whole fraction undefined. Okay.
Thank you.
We're good?
Yep.
Moving on to the next slide. All right, so don't get caught up with what's y sub 2, what's y sub 1. When I start doing them, I literally just try to figure out what would be easiest to subtract. So what's 5 minus a negative 2? 7. There's my change in y. Change in x, what is negative 1 minus 4 more? That's a negative 5. So my slope is negative 7/5. And yes, if you want to sit there and plug into the formula, feel free to do so. Sometimes some of us need to actually be able to do that, and that's okay too. The problem here is if I make a small mistake with my negative, I'd be a fool, and I just lost points. So same idea, and it doesn't matter which direction you go. If you go negative 2 and 5, 4, negative 1, I'm going to end up with the same ratio as before. So like I said, don't get caught up with which is y sub 2, which is y sub 1. Just pick one to be it and do it. Okay? It'll be more important later on when you get into calculus. But I think you can see why, right? All right, can I change the slide? Here's some familiar graphs. Positive slope on these, negative slope, 0 slope, undefined slope. Why is this one 0 slope and why is this one undefined? Anybody tell me why? All right, only 3 people at a time. I can only, no, I'm just kidding. 1. Go ahead, what do you got, Thomas?
The 0 slope.
Why? Yeah. Why is this one zero slope while the other one is undefined slope?
Well, the
I mean, they're both
there's-
similar, right? I mean, all lines are straight.
Yeah,
but
but yeah. The
I know what you meant. I know what you meant.
Yeah.
But it's not necessarily true because all lines are straight.
It's because the undefined slope doesn't pass the vertical line test.
Because it doesn't pass the vertical line test. But the vertical line test is for determining whether something is a function or not.
But
A line doesn't change.
What happened?
X doesn't change.
X doesn't change?
The rise over run is like weird.
The rise over run is weird. Yeah. If you think about it in terms of rise over the run, if I'm looking at this one, do I have run?
No.
No.
Yes.
Yeah, I have run. I have run, right? So I could call this, I don't know, 3, 4, 5, whatever the heck I want, because I do have run. I can pick any 2 points, but do I have rise?
No.
No, which means that this fraction turns out to be no. 0. If I have 0 5 pieces, I have nothing. So there it's 0. But looking at the other one, do I have run?
No.
I don't. I do have rise, and again, I could pick whatever rise I want because it would be true, but there is no run, making this fraction undefined. And that is the different, that's horrible, U. I was trying to write a U and it just ended up being squiggles.
Wait,
It's like an M, huh?
Mr. Munoz,
Yeah.
are all lines considered functions?
All lines are functions.
Okay, so
Not all functions are lines.
okay, so if
Whoa.
so by doing the vertical line test, you see that
This one does not.
yeah.
This one, yeah, so who said something about vertical line earlier? Technically that's true if we're talking about function world, but we're talking about slopes. But yes, mostly all lines are functions except for this one here. Because this one definitely fails at every point. Good question. Anybody else? Good one. I like that. Thanks, Ernie. Moving on. If you like this one, more power to you. I'm not a fan of the point slope. I like slope intercept. I've been doing slope intercept since 6th grade or wherever we did it. And I like it and I got good at it. So everything that I do will be slope intercept. If you want me to do something in this other method, please do so. I can do it. I'm trained for it. But I like slope intercept. It is my BFF. Can I change this? All right, moving on. Oh, here we go. This one's my example. So in this case, they want me to find the equation of a line that passes through the point 2, -5, and it has a slope of 6. Now, I'll do this method and I'll show you what I would do so you can have both of them. What's nice about this one is that all the information is already there, right? So I'm going to plug in my m of 6, x minus x of 1, and then put a bigger parenthesis there. My y should be here, so that's my -5. Here's my 2. So I've got y plus 5 is 6x minus 12. And then all I have to do is to bring over my 5. So I'm going to go -5 minus 5. Okay, so good stuff, really nice. Actually, that was kind of fast in this case. With the other one, if you're going to do slope intercept form, then you've got y is equal to 6x, and I should have a parenthesis there as well. Sorry about that. So 6x plus b, and what I'm after in this case is b. So I'm plugging in my points. Did I do it right? I see that's 12, so I'm going to take away 12 to both sides. That's gone. So my b is equal to -17. So I know that y is equal to 6x minus 17. And again, they're the same one. So whichever one you choose, go for it. Personally, I like the blue. Feels like it's less work for me sometimes.
I hated learning this.
It's always nice to have different tools in the toolbox. So, I mean, but personally I say pick one, get good at it, and then worry about the rest. You know what I stopped seeing though? They stopped showing the 2-point method. You guys ever see the 2-point? It was bleh. It was bleh. Just for kicks. You guys want to see the 2-point one?
Yeah.
So it was y minus y sub 1 is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1 times x minus x sub 1.
What the? That's disgusting.
We're not just adding the slope formula.
Yes, exactly. It's the point slope, but because we don't have it another point, all we're doing for slope is plugging in the slope formula. So if I have 2 points, I can plug all that in there and then simplify it, and then, yeah, too much work for me. I'll pass, thank you. Okay? Cool. Here's my BFF. Y equals mx plus b. So graph using the slope and the y-intercept. There's only 2 things that you really need in order to graph a line. Well, actually, yeah, there always is. It's either 2 points, or you can get me a point and the slope, or you can get me that point and slope. Yeah, that's exactly what it is. Anyway, so graphing from here. Everyone knows where I start, right? Where am I starting at? At the y-intercept, which we call? Thank you. My slope, my y-intercept is at 0, 1. Please don't say the intercept. We mathematicians know that we say, oh, the y-intercept is 1. Yes, but we don't talk for us. We talk for people that don't have a clue. And if we say the y-intercept is 1, swear to God, I've seen this. They'll graph it right there. Okay? We mathematicians know what we're talking about, but sometimes other people don't. So let's make sure that we keep our vocabulary consistent and that we know what we're talking about now. So I'm going to start here at the point 0, 1. From there, I'm going to follow what the slope says, which means
3 over 5.
okay.
You can go either way.
No.
It doesn't really matter. You have to go down.
That's two.
Well, the thing is, if you're going to go to the negative side, then you just go to the right 5 and then down 3. Because it's going to be the same way.
I
if you
thought
go
it was
up
the
5.
right 3 of 5.
It can be either way. If you're going to do negative, you just have to reverse the original thought.
No, you can go over to the 3 and then up to 5. Wait. Wait, so you go over 5
Down
and then down.
3.
Right.
Hold on, did I just crush your world?
No, it's fine.
Okay.
Down 3 over 5, not up 3 over 5.
I thought it was
No,
the
it's
right
both.
3.
No, you go up because it's the line. Well, you can
Now you got this. Look at him.
Okay, so basically, you can't go to the right 3 because the top is the rise. Rise or decrease. Run is right or left. So the rise is going to be up or down.
So what's
I just threw a brick.
hate you?
How dare I?
And that is the same thing. But you can't take the 3 and use it as a run. That's always going to be rise.
It's still increasing.
Yeah.
You're just starting at a lower point. It's still going to go up this way.
You okay with what I did? So here's all I did.
Run is 1. Yes. But it's going to be
Here's your point for those of you that want your 3, 5. All I did was create an equivalent. I graphed the next point as -3, -5 because negative or negative makes a, which is still legit. I'm playing by the rules. I just went the other direction. Woo! Did you see it move?
Yeah.
I was so proud of my line.
What?
Thank you.
That's what I did.
Questions here? All right, let's move on. That was a great discussion. All right.
For you.
Horizontal lines will always be in the form of y equals. Horizontal lines will always be in the form of y equals. Vertical lines will always be in the form of x equals. Vertical lines will always be in the form of x equals. Nothing new there, right? Here's your general form, your standard form. Actually, this is general form, not standard form. ax plus by plus c is equal to 0. slope and the y-intercept of the line whose equation is 3x plus 6y minus 12. If you have an equation that's in standard form, general form, you can always find the slope at negative a over b. So the slope here is negative 3 over 6, which is negative 1/2. You guys catch that?
Yes,
This only works, here's my caution to you, it can only work if it's in standard form or this general form. Standard form or general form. You'll find your slope at opposite A over B. Okay. Now for the y-intercept, you might have to do a little bit more. We know that it's find a y-intercept, what has to be the value of x?
0.
0. So this is out of the picture, which means I got 6y is equal to 12, which means that y is 2, and my y-intercept is?
0, 2.
Thank you?
2, 0.
0, 2. So y inter 0, comma 2. Questions there? Where was negative a over b when that was in algebra 1?
Honestly.
Oh, did you use something else on your daughter?
No, remember I told you what happened. We'll talk about it later.
I just like saw her nails and I was like, mine is still going strong. This is like almost 2 weeks.
Wow.
Yeah. Isn't that crazy?
All right, using the graphs, sorry, not using the graphs, using the intercepts to graph. I'm not a big fan of this general form. I'm not sure why they're doing it this way. You want to make sure it's in standard form, which is going to be 3x minus 2y is equal to 6. And if you haven't used the intercept method to graph, you've been missing out. If I want to find the y-intercept, x should be 0, correct?
Yes.
So that means that all of this is gone, and the y value is going to be how much?
Negative 3.
-3. So I can graph that. 1, 2, 3. There's 1 point. Now I can do the same thing with the other. I'm going to find an x-intercept, which means x is 0. Sorry, y is 0. That's out of the picture, which means x is 2. So I'm going to graph 1, 2. There's my other point. Put a line through those, and you are done.
Right there, 1 second. You just don't move.
I'm ready to go home and do some homework because I'm productive.
I go home and sleep. I don't care about productivity.
See, I'll like sit on the couch and be like, oh, I'm super hungry. I'll sleep whenever I get up and then I don't get up.
Well, what do you get there?
Shame on you. All right, here are all the nice
Teriyaki chicken.
forms that are out there.
I get the
General form, vertical line, horizontal line, slope intercept, point slope form. Do you guys really need that?
I mean, I wrote it all down already, so. Wait.
Okay.
You guys can go back on this.
What's the difference between general form and standard form?
Here's what I'm seeing. In general form, you've got this. In standard form, you're supposed to have ax plus by equal to c. I don't like that general. General. Unless it's attached with so chicken. General So's chicken, you never had that?
I got you, queen.
It's like an orange chicken, but it's got more chili in it.
I choked on that and my grandpa didn't notice.
What
I
is
was sitting there
standard
toasting it. He's like,
TV?
you have beautiful eyes. And I was like,
No.
he's like, and I was like, and he was like, no, he didn't even
I know, that's why I said I don't really like them throwing in that general form. It just makes everything weird. You want standard. I like standard. Okay. Applications. AKA word problems. Use the data points, blah, 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 to obtain a linear function that models the average global temperature for f of x for atmospheric carbon dioxide concentration in x parts per millions, and then round m to 3 decimal places and b to 1 decimal place. So anyways, the important part here is going to be, can I get myself an equation of a line? So I'm going to go with 5764, take away 5704, that's going to be over 354 minus 317. Use my hand to calculator around, huh?
I got it. It's 37.
All of it is 37?
0.0 over 37. I mean, 0.60 over 37.
Which is?
0.0162162162.
0.0162?
Yeah.
All right, so there's my slope. I'm going to confiscate that. How do I get B?
Plug it in.
Plug what in?
The points.
What point?
The X and the Y.
Which one?
Either one.
Either one. So pick one. Does it matter which one?
No.
You'll get the same thing.
Yeah.
So I'm going to pick the smaller values. Well, I did that wrong, didn't I?
Yeah.
57.04, and this should be the 317
Yeah.
plus B. So once you find that for B, plug it back, you're good to go. Questions there?
Good.